Swayam Prabha. Digital India. Educated India.
Hi friends, now we will discuss on the topic characteristics of crude oil and petroleum products. In the last class we have discussed on petroleum. We have seen that what petroleum is, how it is produced and how it is different from crude oil, and we have also seen some types of this and some issues for its utilization. In this class we will discuss on the characteristics of petroleum, both crude as well as its different products. So, content is crude oil properties, then impurities in crude oil and methods for estimation. How we will estimate, that we will also cover in this class. Now, we will see the properties of petroleum. So, petroleum has some properties which are interesting for us as we are dealing with its utilizations as energy feedstock. Like coal, it also has some properties, but unlike coal, this petroleum is mostly used to produce transportation fuel. So, the properties which are most important are density and API gravity, rate vapor pressure, pour point, viscosity, flash point, cloud point, wax content, asphaltene contents, carbon residue, ash content, distillation characteristics. Distillation characteristics is important for this, because if for a pure compound we get a specific boiling point, but petroleum is a mixture of compounds, a large number of organic compounds, hydrocarbons are present in it. So, each will be having different boiling points. So, when it will go for distillation, so then different component will be vaporized at different temperature. So, we will not get a specific temperature for this petroleum crude as a boiling point. So, we will be having some initial boiling point and one will be end boiling point for a particular cut or particular sample. Then we have base of crude oil, there is also one important parameters, and then carbon and hydrogen ratio, and octane number, cetane number, diesel index, smoke point and flash point are also related with the application point of view for some petroleum crude petroleum products. Like some example, smoke point is used for kerosene, octane number is used for gasoline and cetane number is used for diesel. And overall heating values is very important as we are dealing with the energy from the feedstock, and different type of impurities are also present. The one is water content, then salt content, then basic sediment and water, sulfur, nitrogen, inorganic acid and trace metals. So, these are the different properties of the crude oil, and we will discuss the importance of these and how to measure these properties. At first we will see density and degree API or API gravity. As you know, density is nothing but mass by volume of any substance, and specific gravity is also used, m by v divided by m dash by v dash, that means with respect to water. So, what is the density of any material and density of water at 4 degree centigrade, that is specific gravity. So, similar way API gravity has been defined by American Petroleum Institute, that is 141.5 by specific gravity at 60 degree Fahrenheit. minus 131.5. So, this is the definition of API gravity as per American Petroleum Institute, and this is used to clearly understand the difference between the fractions of petroleum crude. For one example, if say if we consider the water, then specific gravity the API gravity will be 141.5 minus 131.5, almost 10. But if it is lower, it is lighter than water, then specific gravity will be less. So, this minus this will be more than 10. So, for kerosene we get 45 API, for motor gasoline we can get 58 API, and for natural gasoline we can get 75 API. So, higher the API, lighter the fractions of the product we are considering. Now, we will see some example of density and API and total distillate up to 370 degree centigrade. So, these are the source of different crude. So, if we see the maximum API is here, say 47.08. So, here we see maximum distillate. So, more the API, lighter, more will be the lighter, that is why more the value of here of the distillate product obtained at 370 degree centigrade. Another property is rate vapor pressure. So, rate vapor pressure, that is the indicative or what are the extent of volatiles present in the crude. So, it is determined under specific conditions, that is 37.8 degree centigrade, and as per ASTM D 323 this method it is measured. So, more the vapor pressure, more will be the lighter fractions in the crude. If we take some example, say in petroleum crude we get C2 to C80 or more than that. So, C1 is very less in this case. So, C2, C3, C4, C5 and C5, these fractions produces the LPG. So, how much LPG we can get from that crude, that be indicated by the rate vapor pressure. So, this vapor pressure, if we consider for propane it is 14.1 kg per centimeter square, butane it is 6.6 kg per centimeter square, whereas for crude oil it is 0.01 to 0.05 kg per centimeter square. Another property is pour point and wax content. So, pour point indicates the flowability of this, that means it is the temperature at which the fuel ceases its flow. So, it is related with the wax content also, more wax the more easy to get to seize the flow of it, and it alongside the viscosity, this is also used for pumping design. And then wax content, as you know that paraffins of having carbon more than 16 is solid. So, this solidified paraffins are considered as the wax in it, and this is determined by angular Holden method, and on this method is based on the solvent extraction method. So, as shown here the two solvents, that is absolute ether and absolute alcohol solvent system is used, and then paraffin wax is precipitated at minus 20 degree centigrade. So, this is the method of determination of the wax. Now, we will see the asphaltenes, carbon residue and ash content. These are also important parameter of the crude oil. Asphaltene basically is related with the residual part. More the asphaltene, we will be having more vacuum residue, and this is nothing but the polynuclear condensed aromatic compounds, and its solubility is also different in different solvents, and we can take the advantage of it for its determination, but it is insoluble in heptane and soluble in benzene toluene solvent. Next is your carbon residue. So, carbon residue, it is a carbonaceous material. So, it is if we evaporate it and pyrolyze it at specific conditions, then it will be remaining some residue. That residue is called carbon residue, and condensation method is used, and ash content we can measure from the proximate analysis, and just like coal, here also ash content is related to mineral matters present in it. Metals which are present, that also contribute to ash, and we can convert the ash into dry basis and wet basis also as provided here. And condensation carbon residue we can determine under specific condition. We will take the wet certain amount of material, we place it in a crucible and subject to destructive distillation during a fixed period by severe heating. After that we will collect the residue, and how much is left, that is considered as the condensation carbon ratio, and it is expressed in terms of percentage with the original sample. Salt content is also one parameter of the crude oil. So, when the crude oil is taken out from the underground, then it forms, it contains different type of material including water and salt. These salts are basically sodium, potassium, calcium and magnesium chloride, and this salt can be present as a crystalline solid or may be dissolved in water, which water can form a emulsion with the organic phase in the oil, in the crude oil. So, as shown here, so one brine droplet, say salt in water, brine droplet. So, this droplet size is maintained by the formation of a layer, and resins, asphaltenes, waxy agglomerates, carboxylates and naphthanates, alkyl benzene, all those things helps to get the stability of this brine droplet, and some brines may also be, some salts may also be available in terms of particulates. So, or solid particles. So, this is a salt, and this salt if present in crude, that will create lot of problem, and above certain limit it is not desirable in the refinery. It will create pollution, it will give the irregular behavior in distillation, it will be fouling the heat exchanger, and it will also cause equipment corrosion. So, these are the disadvantage of the salt, and if we think about different type of salts, mostly sodium is used at 70 to 75% typically, magnesium 15 to 20%, calcium is around 10%, and magnesium salt mostly gives HCl. So, that is corrosive in nature. Then for the determination of this salt, some methods are available, that is here silver nitrate and Kc and S method by titrations, or by conductivity measurement based on the standard sodium, calcium and magnesium chlorides and standard solutions in mixed alcohol. So, these are the method which are used for its determination. Then metals which are available, in the crude oils are mainly lead, nickel, vanadium and copper. So, it will also contribute on the ash, when it will be burned, then soot will be formed and particulates will be formed, and it poisons the catalyst. So, the lesser the metals, more we will get the quality of the crude or of the derived product from it. Now, this can be measured by using atomic absorption spectroscopy, and another property, sediment and water. So, as we told that when the crude oil is taking out, then it contains salt, different types of sediments which are basically sand, clay, volcanic ash, drilling must, rust iron sulphide and metals, and different types of scales. So, these contribute the sediment, and water is already available in the crude oil. So, the presence of this affects the process of refining, and it is damages, there is plugging, abrasion and residual product contamination. So, these are the important effect of these contaminants on the crude oil, and water causes irregular behavior in the distillation, and for the measurement of this there are a number of methods, that is base sediment and water measurement, ASTM D96, sediment by extraction ASTM D4007 and water content DIN and star or ASTM D4006 method. Now, we will be discussing some properties of the refined products, that is your octane number. Octane number is the property of the gasoline and it is related with the knocking property of it. What is the resistance of a motor fuel to knock, this indicates. So, more the octane number, more the quality of the gasoline, and this is also called octane rating, and octane number are based on a scale on which the isooctane is 100 and heptane is 0. So, if we have a fuel which burns in the similar way, which is having the similar knocking property with a blend of isooctane and heptane, in that blend what is the percentage of isooctane, that will be the octane number of this fuel. And for the determination of octane number, some standard machine is used in laboratory. So, in that case what number octane number we get, that is called research octane number, and it is determined by running the fuel in a test engine with a variable compression ratio under control condition, and comparing the results with those for mixture of isooctane and n-heptane. As I told, what is the percentage of isooctane in this mixture, that will be the having the similar knocking behavior, that will be the octane number. So, this is motor that is called your research octane number, and when the vehicle will be on road with actual loading, then it will be consuming some amount of more energy. So, motor octane number is also used. In this case higher RPM is used, whereas that is equal to 900 RPM, but for RON it is 600 RPM. Another property, that is anti-knock index, is also used in some country to get the knocking behavior of the gasoline, and this is defined by R plus M by 2 research octane number plus motor octane number divided by 2. Then we come to cetane number. So, cetane number is the property of diesel. So, it is a relative measure of the interval between the beginning of injection and auto ignition. So, how much time it is left, that is the indication of the cetane number. And again like octane number, there are two compounds here, the cetane which is having 100 marks and 100 number, and then for 1 methyl naphthalene it is 0, and isooctane is also 15. So, 0 and 100 will be blending with different ratio and use in the specified machine, and we will get the delay period, and then that will be, and the percentage of cetane will be the cetane number. So, cetane number is measured by burning the fuel in a cooperative fuel research engine under standard test conditions. A wheel is there, hand wheel is used to increase the compression ratio, and then this compression ratio is increased until the time between the fuel injections and ignition is 2.407 millisecond. So, then this cetane and N1 methyl N naphthalene mixture is also used in the similar way on the same compression ratio, then time requirement is considered, and then for the composition which is having the same time, that will be in that mixture the percentage of cetane will be the cetane number. And another is your aniline point and diesel index. So, for diesel cetane number is measured, for other fuels like say lubricating oil etc., for this diesel index is measured, and diesel index is defined as aniline point in degree Fahrenheit into API gravity divided by 100. So, aniline point is measured first, then diesel index is measured. So, what is aniline point? It is the temperature at which equal volume of aniline and the lubricating oil will be mixed. So, if we get that temperature, we will put it here. If we have the degree API of the fuel, then we will multiply it by it and divide by 100, we will get the diesel index. So, next is acid value. So, crude also have some acids, organic and inorganic acids may be available in it, and total acid content we can measure by its titration with the base solution, and it is defined as total acid number TAN, that is equal to mg KOH required to neutralize all the free acids per 1 gram of crude. So, this is our total acid number. Similarly, total base number is also determined by the titration using perchloric acid. Viscosity is another property of the crude oil which is very important for its transportation and for pumping purpose. As you know, the viscosity indicates the resistance when one layer flows on the other layer, that is the fluid, one fluid layer is flowing on the other layer, that is experienced and that is related to the viscosity. So, it also refers the thickness of the oil and is determined by measuring the amount of time taken for a given measure of oil to pass through a orifice of the specified size. So, for the determination of viscosity, what happens, for a simple arrangement we can make, we can pass the fluid through a orifice and what time it is taking we can measure it, because this is a flow through a porous channel we can consider, and in this case we can use the Poiseuille's equation, that is your eta is equal to pi r to the power 4 p into t divided by 8 into v into L, when we get the eta is viscosity coefficient and p is the hydraulic pressure and t is the time of falling and v is the volume of liquid collected and L is the distance travelled by the liquid during time t, and r is the radius of the tube. So, in this formula we can say this pi radius of the tube is fixed, v volume how much liquid we are collecting that can also be targeted and fixed, and then L is the length of the distance travelled by the fluid. So, that L is also fixed for the system. So, we can getting eta is equal to k into p into t, k into p into t, that this p is nothing but related to, p is the hydrostatic pressure. So, hydrostatic pressure that is related to mgh, so mass of the oil. So, we will be having, it is proportional to epsilon, eta is proportional to k mt we can get, because p is proportional to m. Now, if we have two fuel, one is standard known viscosity, another viscosity is not known, we are getting what is the time to fall certain distance through the orifice for both the oil samples, then we will get the viscosity coefficient ratio by this mt by mrtr, where mr is the reference mass of the reference fuel and t is the time required to travel the same distance by the reference oil, and this is for our which I want to determine t, the time required by the oil which we are interested to get the viscosity, and mass is the mass of that oil for which we are interested to get the viscosity. So, now we can get the value of viscosity coefficient. So, this viscosity can be measured by different ways as mentioned here. Viscometers are there, Oswald viscometer, falling sphere viscometer, falling piston viscometer, oscillating piston viscometer, vibrational viscometers, rotational viscometers and bubble viscometer. Another property is flash point. So, if we heat any fuel, it will produce vapors. So, if we can bring one matchsticks or for ignition, so immediately a temperature will come at which sufficient vapor will form and flash will take place at the first time. So, that temperature is called flash point. If we apply more heat and temperature will increase and more vapors will form and fire will take place, and that time that temperature at the minimum temperature at which fire takes place, that is called fire point. So, flash point and fire point are the properties of the liquid fuels which are produced through the refining of the petroleum crude, and it is determined in open cup system and closed cup system. In open cup system, the flash point varies with the height of the flame above the liquid surface, and at sufficient height the measured flash point temperature coincides with the fire point. but in case of closed cup there is a lead and we bring the ignition source for a moment and we get the flash. So, it has been shown that the values of flash point in case of a closed cup is normally lower than that obtained through open cup, and it is typically 5 to 10 degree centigrade lower. Then asphalt properties, asphalts which are present in the crude oil, that will be available in the residue, vacuum residue, and this is made of some polymeric compounds and it is aromatic rings are present in it as we discussed, and it may be directly used, that is the straight run, that means starting of vacuum unit or PDA propane deasphalting. So, vacuum residue we are getting, that is directly we are using, or we are separating the lighter part from it by propane deasphalting and using the asphalt. So, that asphalt is called straight run asphalt, but cut back. So, cut back means we are using some solvent here. So, rapid cut rapid cure RC, that may be naphtha diluent. If you use the naphtha, then that is called rapid cure. We can use kerosene with the asphaltene, that is called medium cure, and slow cure when gas oil is used. Apart from this, emulsion asphalt is also available when the water is added with this 30 to 50% water plus emulsifying chemicals, then gives the emulsion asphalt. And then industrial blown asphalt, another type of asphalt is also available, which is formed by the air blowing in the hot asphalt, and these asphalts, that is industrial or blown asphalt, these have some applications as a waterproofing material and it is harder than the asphalts. So, it has some properties, that is a softening point and hardness. These properties are measured to assess its quality. The softening point is the lowest temperature at which standardized weight and shape will sink into asphalt, that is around say 80 to 340 Fahrenheit, and hardness, it is the depth to which a test needle penetrates into asphalt over a time at specified temperature, as a certain condition is maintained, and what is the depth the penetrating needle is going inside, that is the hardness, related to hardness. So, 0 pen, 30 to 40 pen millimeter and pen, and 250 to 3000 millimeter pen is reported. So, there are some impurities in the crude oil also, like say sulfur, nitrogen and oxygen. So, the sulfur is present in elemental form or in case of sulphide or oxide form. Some organic sulfur is also present and those are called mercaptans. So, different products have different types of sulfur, as for example, present H2S and mercaptan in LPG, sulfur and mercaptans in gasoline, kerosene, ATF. And to remove the sulfur we can use some sweetening process, that is caustic washing, mercaptan oxidation, etc. And nitrogen is present in the elemental form and also as oxides of nitrogen, and it forms acids and causes corrosion. So, removal is necessary to get on grade products and secondary units feedstock. And oxygen present in the elemental form and also as compounds of oxygen, it forms naphthenic acid and causes stress corrosion. Now, sulfur content is may vary, it may be low sulfur up to 0.5%, it may be medium 0.5 to 0.8% or may be high greater than 0.8%. These are some example of different crude oil and different sulfur content. So, we get medium and high as well as low. So, crude oil and their sulfur content. So, method of sulfur determination, there are number of methods. So, some important are colorimetric method or barium sulphate method, it is also known as, and weak bond method and the combustion method this is, and then X-ray fluorescence method and ICP-MS. So, these are the different methods I have mentioned here. These are the test number, and these are detection limit, and these are some interference which can the compounds or elements which can interfere on the detection. So, for the nitrogen, so it is poor color stability of products. Nitrogen gives poor color stability of products, it is poor stability in storage and handling also, and poor quality of feedstocks for catalytic processing. So, removal of nitrogen is important and required. So, now we see the different crude and presence of nitrogen and sulfur in it. Nitrogen can be determined by some methods, that is microcolorimetric, chemiluminescence, microgeldal and modified geldal. So, these are the methods through which nitrogen is determined, and different products are used for this purpose, and detection limits are also given. Apart from this, CHNS or elemental analysis can be done to measure the carbon, hydrogen, sulfur, nitrogen and oxygen of the crude oil sample. So, up to this in this class on the characteristics of crude oils and the petroleum products. Thank you very much for your patience.